Good morning. Today we are going to see the on-demand routing protocols. In table-driven protocols, each node maintains up-to-date routing information to all the nodes in the network. Wherein on-demand protocols, a node finds a route to a destination when it desires to send packets to the destination. This protocol is an example of reactive routing protocol which does not maintain routes but build the routes as per requirements. That means route is established only when it is required by a source node for transmitting data packets. AODV is used to overcome the drawbacks of dynamic source routing protocol and distance vector routing protocol. That is, dynamic source routing is capable of maintaining information of the routes between source and destination, which makes it slow. If the network is very large, containing a number of routes from source to destination, it's difficult for the data packets header to hold whole information of the routes. In case of dynamic source routing, multiple routes are present for sending a packet from source to destination, but AODV overcomes this disadvantage too. In AODV, along with routing tables of every node, two counters including sequence number and broadcast ID are maintained. The destination IP is already known to which data is to be transferred from source. Thus, the destination sequence number helps to determine an updated path from source to destination. Along with these counters, route request and route request response packets are used in which RREQ is responsible for discovering of routes from source to destination, and route response packets sends back the route information response to its source. Ad hoc on-demand distance vector routing protocol. Its working is in ad hoc on-demand distance vector routing, the source node and destination nodes IP addresses are already known. The goal is to identify, discover, and maintain the optimal route between source and destination node in order to send or receive data packets and informative. Each node comprises of a routing table along with below mentioned format of RREQ packet. RREQ of destination IP, destination sequence number, source IP, source sequence number, hop count. The IP addresses of source node X and destination node D is already known. Below mentioned steps will let you know how AODV works of concept route request and route response is used. Step 1. Source node X will send route request, that is R request packet, to its neighbors Y and Z. Step 2. Node Y and Z will check for route and will respond using RRESP packet back to source X. Here in case of Z is the last node but the destination. It will send the RREQ packet to X, stating route not found, but node Y will send RRESP packet stating route found, and it will further broadcast the RRESP to node T. Step 3. Now the field of net hop in the RREQ format will be updated. Node T will send back the route found message to node Y and will update the next hop field further. Step 4. The node T will broadcast an RREQ packet to node D, which is the destination, and the next hop field is further updated. Then it will send RRES packet to T, which will further be sent back to the source node X via node Y, and node T, resulting in generation of an optimal path. The updated network will be like this. Here the advantages of this particular routing are dynamic networks can be handled easily, no loop generation. And coming to the disadvantages, a delayed protocol because of its route discovery process, then high bandwidth requirement. Thank you.